Hello, we are Team Jarvis and I'm Umkar. The title of our project is Windowed Query Execution. The problem we are trying to solve applies mainly to UI-driven data management. As the data shows, users tend to lose their train of thought, and we are eventually likely to leave if UI we are using is slow in responding. The image on the bottom right captures what we mean by a window. All the current systems that are in place calculate the tuples from the result of a query that are not part of the visible window, which leads to slower UIs and also increases the memory and processing power required. For example, what we are trying to look at is if a user is already on Windows 5 and wants to get to Windows 10, is there a way to not have to calculate Windows 1 through 4 again, thereby improving performance? The existing constructs that are somewhat promising in providing a solution to this problem are offset and the limit clause. The offset clause retrieves tuples from the result that start at a desired number. The tuples from the query without offset are still computed. They're just not returned. So it's not really a solution. Limit clause returns after the specified number of tuples have been found, but this is usually used with the offset clause and comes with all of its problems. So the main challenge is to select the right index to start your execution at in order to retrieve the tuples that fit in the window that the user wants to look at. This is hard because of the different conditions present in the where clause and the need to essentially predict or estimate the number of valid tuples in the result.
This is Rohit here. So I'll walk you through our initially proposed solution. So our goal is to actually develop a program which can avoid the computation of the tuples which are not displayed in the current window. So the idea is actually to use the offset of the last record in the current window and add the distance between the current window and the target window offset and filter out based on the where clause by using the last value in the current window. So in the slide on the right side you can actually see how we are actually doing it. So I'm actually filtering out based on the last value of the last record, and in the offset I am actually specifying the difference between the target window and current window's offset. So we can actually extend this idea to the join query also, and probably we'll be extending this idea for the even more further complex queries.
Ish, and I'm doing the evaluation portion. We have created two tables, school and person, to test the performance of our windowed query optimization. The school table has 5,000 rows, and the person table has 1,000,000 rows. We have tested 5 queries on these tables. Here is a graph of the 5 queries we ran, and you can see the optimized solution is much faster. The first 3 queries retrieve windows from the person table. The third query's optimized solution does not show as great improvements as the other two, since for the first 2 queries, we are in a window directly before the desired window, and in the third query, we are in a window that is 500,000 rows before the desired window. The fourth and fifth queries do joins on the person and school tables, and you can see there's great performance improvements on these 2 queries.
Hi, this is Adam. I'm going to present our prototype application for modifying SQL queries on single tables. This program is written in Python and takes as input a SQL query along with parameters related to the current and desired windows. So shown here is the original query that we're going to modify. And then we can run the program. It takes several inputs. These first 2 are related to the current window indices. These next 2 are the desired window indices. These last 2 numbers are the order column and primary key, the last values in the current window. And so then we get as the result the modified query. So as you see, the where clause is updated. We have this extra part to it that will filter out results we know will not be in the desired window, and then we get a updated limit and offset clause depending on what window size we select. So for the original 4 milestones in our proposal, we finished the initial version of the first 2. Our next step will be integrating the program with data spread so we can ensure they are compatible before extending our application to more complicated queries. Finally, we plan on evaluating and experimenting within DataSpread to see if there's any additional optimizations that can be made.